Welcome back, guys. We are on to chapter 55, on to part 3. And this section is just going to take a look one more time at energy transfers and sort of the efficiencies that are going on between one trophic level to the next. And we keep bringing up this approximate 10% efficiency, so going from primary producers to primary consumers to secondary consumers, so on and so forth. We tend to have about 10% of the energy from the previous level that's capable of being transferred up to the next. Alright, and that's what we mean by that energy transfer. The amount of chemical energy in a consumer's food is what gets converted into that new biomass, and within that given period of time, that accumulation of biomass is really what we're talking about as secondary production. All right, and it's that secondary production that is what's kind of really going to be capable of being passed along. Okay. So what we end up looking at is sort of this production efficiency. We say it's about 10%, but there is a range depending on the organism you're talking about, the conditions that an organism finds itself in, so on and so forth. So when we talk about production efficiency, we're really looking at the fraction of energy that gets stored in the food that isn't used for respiration, that isn't lost as sort of feces or heat or waste of any sort. All right, and it's that production efficiency that really then does make it to that next level. All right, so the mathematical equation, we're looking at sort of that net secondary production, so how much biomass are we creating? Multiply that by 100%, but then that whole thing gets divided by the assimilation, how much actually gets utilized, gets stored as primary production. We've got to get rid of it. We can't count it as being utilized for that own organism's purposes. And so what we see is your fish organisms are about 10% that they get to pass on, where your birds and your mammals have a much higher cost for their own body heat and stores of energy, and so they're only passing about 1 to 3% up. But take that on the other extreme, and you've got insects and microbes who don't need to assimilate as much of their own production, and so they're passing on somewhere on the order of 40% or more. So kind of level all that out, and that's where we get that 10% from. Okay. So we can talk about your efficiencies in pyramids. All right, your trophic efficiency, which is where that kind of average 10% comes from. And that's what that picture is showing. So we bring in, 1,000,000 joules of energy via sunlight, but only 10% of that actually gets used for photosynthesis. Only 10% of that actually makes it to the primary consumers, and so on and so forth. So that's why we can't have infinite numbers of trophic levels. We run out of energy. Okay. And although we typically talk about 10%, it can actually range anywhere from 5 to 20. All right, you're really on a good day if you get 20% transfer, kind of on a lower end if you get 5, but you take the average and we're somewhere around 10%, which is what most students know by this point. We can also look at biomass pyramids, similar idea, but now we're looking strictly at the dry mass that is in each trophic level. All right, but we do see a much sharper decrease. It's not 10% anymore, it's much lower. Okay. And in our aquatic ecosystems, we almost see a reverse. All right, there's more zooplankton than there are phytoplankton. So that's sort of an interesting concept as well. We can also look at your pyramid of numbers, similar idea in the sense that you've got a lot more producers at the bottom and many fewer top consumers. Again, that should make sense. As I go up each level, I've got less energy available to me, and so I'm not possibly capable of having a high number of organisms at that secondary or tertiary level because there's just simply not enough energy there to sustain those numbers. So if we take a look at it from a human perspective and sort of throwing ourselves into the food chain, it's very interesting to study the dynamics of that energy flow on the implications of our human population size. All right. Most of us, myself included, are quite the fans of eating meats. All right, your cattle, your chicken, so on and so forth. But it's a much more inefficient way of getting the energy that we need because we're putting ourselves in that scenario at a secondary consumer level. All right, so sustainably wise, we can't sustain as many humans in that sort of a food chain versus if we were all vegetarians. Now all of a sudden we're down here and we're primary consumers, we can sustain a much larger human population eating strictly plants rather than eating our livestock. All right. Don't know if that's going to convince me to not go have a burger later, but that is the basic principle, and sheer numbers wise, sheer energy wise, it makes sense. All right. So, just some food for thought.